We also calculated, and there's very standard calculations, the amount of energy contained in the magnetic components themselves. So we have 4 sets of rotor magnets, and we threw in the bearing magnets for good measure. And the inherent energy contained in the permanent magnets in the system is calculated at 2.3 joules. This surprises a lot of people, but there isn't an awful lot of domain energy in a magnet. If you look at the amount of excess energy produced, and I stress excess, that is the differential between input and output, during the week-long test, we generated 21 kilojoules of excess energy. And we measured the components afterwards, and there was absolutely no degradation of the components of the system itself. And what this demonstrates in a very dramatic way, the numbers from 2 to 21,000 are very large, is that the drawing of excess energy from an orbo system is not in any way related to the component parts itself, and that's obviously a very key point. So the final bit of the experiment that we're going to conduct is to actually show you a live system, which we have here in front of us, and to show you the classic more energy out than in. And I keep saying that the wrong way around, so you'll forgive me if I do. And what you see on the system here is something very similar that you've seen if you've been watching any of these videos before. It's a rotor with 4 sets of permanent magnets. We have 4 coils. We're using an optical switch to fire at certain angular positions. We're providing a DC current into the system, and the optical switch turns the current on when the magnets are at top dead center and turns them off maybe 20-30 degrees later. Connected to the system, in addition to the input coils, is a pickup coil, which is this one here. This pickup coil is capturing some of the kinetic energy of the rotor, or the motional energy of the rotor, and converting it into a voltage current. For this test, we've shorted out the coil, so it's effectively acting as a heater. We're measuring 2 things. We're measuring the input current with a current probe, and we're measuring the input voltage with a differential voltage probe, and we're measuring the output current. And if you look at the scope traces, what you will see in the brown scope trace is the energy of the output coil, and that is basically I squared R, and that represents the heat produced by the system. The purple trace is the net electrical energy put into the system, net of joule heating. You can work the ratios. It's about 3 to 1 input to output. This does not include the energy that the rotor itself is doing in terms of work. That is simply direct electrical in to out, net of joule heating. At that speed, I think we're probably doing about 1.5 to 2 millijoules a revolution, and we're operating, I think, at about 1,500 RPM, if I can check that. Yeah, 1,300 RPM. Of course, there's a lot more energy that we could capture, and as a simple test, what I'm going to do is simply to push the coil in closer. You'll notice, if we can just focus on the scope, guys, that the output energy increases. So if I take it away, the input energy is remaining the same, and the input energy is remaining the same because we have no counter EMF. So there's no change in the input energy due to the speed of the motor, but as I can do that, I can basically go off the Richter scale. So a lot of people keep questioning how efficient is orbo, and the answer is how efficient do you really want it to be, and it comes down to physical and practical design issues. So, actually, you just fix the pickup coil in again. If you look at the system as really being 2 systems, what we have is, in this case, 4 sets of coils and a drive circuit. And if you were to analyze, which is the inductance energy, this steady state part of the system, you'll find that you're sitting at about 108% efficiency. What this is really demonstrating is that there's no coupling between the electrical energy that's put into the system and the rotational energy of the rotor itself. If you look at the efficiency of the rotor, in essence, you could call it infinity, since there's no direct energy transfer between the steady state element of the system and the active element of the system. If I was to show you and say, we'll give us some specific numbers, and people are more than welcome to come and play with this afterwards, but we did this test earlier today. Doing live experiments is always a dangerous game. And if you took this, which was from earlier today, the net efficiency during this run, electrical to electrical, I need to be clear about that, is 327%. And that excludes any work done by the system against friction, which is limited because we're using magnetic bearings, air resistance. Obviously, this is a experiment being done by us on our test equipment, and we're aware that some people will have concerns about that. However, we've tried to present this in a cogent way and in a transparent way, and I would encourage anybody who's in the audience to come and have a look at the system afterwards. However, what we're also offering is from Wednesday of this week, anybody can book and come in and test this with our engineers. All that we ask is that you book it. The details will be on our website from, I think, tomorrow morning. You can come in, you can bring your own test equipment. We've decided to extend our stay here in the waterways until Friday the 26th of February to enable that. And that is really the last offering from Steorn in terms of validating the technology. And we can really do no more than that. What we are about, for those who are suspicious or perhaps cautious of our own experiments, but what we're really about is getting this technology into the hands of the development community. And on Monday, we open our developer forum. And our developer forum is the place where you can learn and understand and implement Orbo. It's being opened on Monday for a group of commercial organizations who have pre-applied, and it will be open to the rest of the developer community the following week. All the test data that we have generated, the digital scope, is stored. It'll be documented along with various other third-party tests that have happened, and that will be available on our website within a few days. We're going to take a couple of days break, I hope that's understood. But it will be up on our website, and anybody can get the data, analyze it, and talk to us about it. And that, folks, is pretty much that. Questions? Yep.
Could you explain this trace? Does this trace definitively sum up what you're saying about orbo technology? Because
Yep.
You know, you're saying that this trace here definitively proves over unity. Can you break down that trace even further? Because I don't understand it.
I guess I kind of really have to come back to where I started the presentation and say,
Could you repeat the question?
the question is, does the trace definitively prove that Orbo is over unity? And the answer is no. You have to take summary of the three tests, and that this is literally an embodiment or encapsulament of these three effects. If we had...
You said the trace is I squared R. I don't understand what the trace...
The trace is integral I squared R. Sorry, the output trace is integral I squared R with respect to time, yeah?
Okay.
That's the output.
So it's showing that it's constantly increasing.
Yeah, well, it's an energy trace, it's not a power trace. So every time that the coil passes, you'll see that as it passes, the energy bumps up, the energy produced bumps up, yeah? So this represents the output energy, and this is the net input energy. So we put some energy into creating the magnetic field, and that's the inductance energy we put in, and we recover some from the collapse of the magnetic field. And so the net, if you look at this is a fixed time period. The net output, excuse me, touch screen, with me here. The net output is represented over this time frame is represented by the brown line, and the purple line represents the net input. But that excludes the work done by the rotor. That's purely the electrical picture. Any other questions? Yep.
You mentioned a very handsome 300%, 320% back. Do you have more powerful configurations than this? I appreciate this is a demonstration machine rather than a...
The answer is yes, okay? But you've got to understand that we're not an academic